Welcome to the first of two short videos exploring how to configure Dbvisit Standby with machines hosted in the Azure cloud. Each video complements an online guide by the same name, the details of which will be displayed at the end of this video. This first video explores how to run Dbvisit Standby when both the primary and the standby databases are hosted in the cloud. The necessary steps to run Dbvisit Standby and create a reliable DR solution within the Microsoft Azure cloud platform. We will look at the network considerations, specifically adding firewall rules, modifying network security groups, and touch on the IPv4 restrictions, then move on to installing the Dbvisit software and setting up a new configuration. We have made the following assumptions: that the primary and standby hosts have already been provisioned, Oracle software has already been pre-installed on both primary and standby machines, and on the primary server there is already a running database that is in both archive log mode and force logging mode. Let's take a look at preparing the servers. In this setup, we have both the primary and the standby hosts within the Azure cloud. Both are running Windows 2016 Data Center and Oracle for Windows 12c Release 1. The Dbvisit standby version will be running is 8.0.14.19191. That's the latest release. As you can see from this dashboard view, I have two virtual machines running. These will form the primary and the standby host in our configuration. Looking at the Virtual Machine tab, you can see as a quick overview that both these machines are running from the same resource group. This means that each machine can automatically see the other via its host name without the need to configure anything in the local host file. If we take a closer look at the resource group, we can see that there's also two network security groups, one for each of the machines. They do share one virtual network, but they have an individual network security group. And it's from here that we need to add the relevant inbound and outbound security rules to allow Dbvisit to talk to each host on its designated ports. Dbvisit uses ports 7890 for the DBVNet, 7891 for the DBV agent, and also port 4433 for the central console or the DBV server. In order for the machines to talk across the network, we need to open each of these ports on each of the network security groups. So here for the primary host, I've created an inbound security rule and an outbound security rule. I've kept it quite straightforward and just opened up a port range. However, it is also possible to create one rule per port. I've done the same for the outbound security rules. And moving back to the resource group, if we have a look on the network security group of the DR server, I've created the same set of rules. Now if we click on one of the virtual machines, to connect to it, we download a Microsoft Desktop parameter file. And that can be configured to have a more meaningful name rather than the IP address. And also you can allow folder mappings from your local host, as I've done so here. So if I go ahead now and connect to the primary host, opening up the network security rules is only half of the equation. On the actual servers themselves, we also need to configure firewall rules. we need to configure an inbound firewall rule and an outbound firewall rule on the same ports. And I've performed this action on both servers. In addition to this, when we look at the networking, by default, Windows Data Center has TCP/IP version 6 enabled. In order for Dbvisit to communicate successfully, we need to uncheck and have only TCP/IP version 4 enabled. We further configure this by unchecking the automatic metrics and popping a value in here greater than 0. Now that the network considerations have been taken care of, we also must look at the user that will install Dbvisit. In this case, it's the user that we created when we created the virtual machine. And for this demo, that user is Dbvisit. So we have a look at the local security policy, and then the local policy, the user right assignment. The user Dbvisit must be granted the log on as service privilege. In addition to this, it must also be a member of the local administrators. With all this in place, we can go ahead and install the software. I've already copied from my local machine to the downloads folder of this host the relevant software. I pre-installed Oracle 12c and a database running in archive log mode, and forced login mode is already running on this machine. So all I need to do is go ahead and install the Dbvisit software. Our central console is supported with Chrome and Firefox, not with Internet Explorer as you get with your Azure Windows 2016 machine. So I've chosen for this demo to download and install Firefox. From our downloads page, I've taken the latest release of Dbvisit Standby and copied it over. And from here, we can go ahead and install the software. Software installation is quite straightforward. First, we select to agree to the license agreement, and as this is going to be the primary host, we won't check the central console in this installation. Select the default installation. We've checked that the Dbvisit is a member of the local administrators. Let's also check that it's a member of the AuraDBA group and the Oracle 12c home group. As you can see, we'll add in Dbvisit. So we can click Next, put in the password of the user, goes ahead and installs the software. So we have the dbvnet and the dbv agent configured, but no dbv server. The install log is located in the app data local temp directory, and then we can click Finish and have a look at the services and see that they've both been installed and they're both running. I also like to use Notepad++. We can look here at the details in the dbvnet configuration. So the local host is the primary and the remote is the standby. And for the agent, it's running on the local host. Once we've performed these actions on the primary host, we go ahead and perform exactly the same configuration, checks for the firewall rules, checks for the user permissions, and install the software on the standby host. And create our Dbvisit standby configuration, it's good to check that each of the hosts are resolvable across the Dbvisit ports. Here I am on my Azure primary cloud server. To do this, I'm going to install the Telnet client, which by default isn't enabled. I connect to the program and features and have a look at the roles and features. And here in the server roles, the features, I make sure that the Telnet client is installed. Once the Telnet client is installed, I can run the command prompt and check that my standby is resolvable across port 7891, which is for the agent, and 7890, which is for Dbvisit. Similarly, from the opposite direction, let's try the same from the standby host. And they both are. We can go ahead and connect to the central console and start creating our configuration. The address of our central console is the address of the standby host across port 4433. The default admin are the connection details that I've used at the moment. So here we are. Currently, only manage hosts and manage users is available because we don't actually have a new configuration. So let's add the hosts. First of all, we'll pick the primary host, the agent, and the passphrase that we used when we installed, which was Kiwi123. We've got a little green tick here, which is good because we know we can resolve the host from within both servers. Let's now add on the standby. It's also a Windows, and there we have primary and standby, both of them available. So from here we can create our first configuration. We'll click New. Our source is going to be Dbv16. We'll accept the license, and we're going to select this archive log database Dbv1. I know that this directory is available, and we know that the port for Dbvnet is open, so we can move on to the standby details. The standby server, I'm happy for the standby database to be called the same. I'm not going to use automatic storage management. I'm going to use file system. I know that that directory is available. It's the same Dbvisit base location on the standby. The home's the same. The database name's the same. And I'm going to call this configuration Azure 1. I'm not going to enter a license key at this stage. I'm going to add the license key after the configuration has been created. As you can see, it's been created, it's in place, and now additional boxes have become available on the console, and it's from here I'll update the license key. So now that we've got a fully licensed configuration, we can go ahead and create our standby. To do this, we select the configuration, Dbvisit standby performs some tasks in the background, making sure that there's not a database by that name already running on the standby site, and seeing if there's a service or SP files around from a previous installation. Okay, so it's come up with a choice, and the only one available is to create a new database. We're going to select the defaults here because the two servers are essentially the same build, so that I know that all the file paths are all going to be good. Okay, let's pop in the Oracle user to this space. We're not going to use transportable media, although on this cloud platform that might be useful. Because this database is quite small, I've opted not to go for that. Instead, I'm going to accept the default, which is C Windows Temp, which again I know exists in both locations. Once I'm happy with all my settings, I'm going to click Submit. Okay, here's our standby database creation. It pops down here into the active task, and we can monitor it. Now from the active task list, we can see that the standby has created successfully. And now that's the case, we can run any of the various actions against the standby. So for example, running a log gap report. We can see that the log gap is now actually 0 because we sent and applied some logs. Other commands of this are some database actions, where we can see the status of each of the databases. We can stop and start the daemons so that the logs are applied automatically. Back from the main window, we can synchronize the database if the log gap was such that it was unrecoverably too large. We can switch over so that the standby becomes the primary, or in the event of a disaster, we can activate the standby so the standby host becomes the primary.